In this video, we'll use average rates of change calculations in Excel in order to estimate an instantaneous rate of change at a point. We're given the function f of x equals 2x squared minus 8x plus 9. We're first asked to find a series of average rates of change. So first we'll find the average rate of change from x is 4 to x is 5. So I have already gone in and created labels on our table. I've put in x is 4. And you see that in Excel, I've already identified the function using cell referencing. I'm now going to go down to the next row and I'm going to put in the second x value, which is 5. And I'll drag down the formula so that it calculates the function value at 5. So we're talking about 2 points on the function, the point 4, 9, and the point 5, 19. To find the average rate of change, we find the slope of the secant line between those 2 points. So that is y2 minus y1 over x2 minus x1. So I take the second y minus the first y, make sure to put parentheses around it, divided by second x minus first x, make sure to wrap parentheses around that as well. And I get an average rate of change of 10. I'm asked to find the average rate of change from 4 to 4.5. So the nice thing about Excel is I can just go in here and only change the x value in my table. I'm going to change the x value to 4.5, and as soon as I do so, we see that it automatically calculates the new function value, y equals 13.5, and it automatically calculates the slope from the point 4, 9 to the new point 4.5, 13.5, and it says that this average rate of change is 9. So the slope of the secant line from x is 4 to x is 4.5 is 9. And again, I'm going to do this a few more times, and you see that each calculation we're doing here, the x value, the second x value, is getting closer and closer to x is 4. This time I'm using x is 4.1. And we see that the average rate of change from x is 4 to x is 4.1 is a slope of 8.2. When I change it to 4.01, it's 8.02. When I change it to 4.001, it's 8.002. And I bet if you had to guess, you could figure out what the next one's going to be. When I change the x to 4.0001, the average rate of change is 8.002. So each of these calculations that we did here is calculating the slope of a secant line, and we're calculating a series of slopes of secant lines as the second x value gets closer and closer to x is 4. We see that the slopes of these secant lines are getting closer and closer to a value of 8, and that is going to be our slope of our tangent line. We'll make that conclusion in just a moment. It asks us to just do one last calculation to find the average rate of change from x is 4 to x is 4.000001. So I'll change this over here, 4.000001. First of all, notice when I type that in, Excel automatically changed that value here to display 4. Now it did that because that number, 4.000001, is too wide to fit within the column that I have. But remember, you can double click in between the A and the B to widen that column so that it fits all the numbers within the column. You're going to need to start doing that pretty regularly because you will have these values that are pretty wide, a lot of digits in these numbers. So when I plug in that x value, it produces this y value of 9.000008, and the slope of that secant line is 8.00000213. And again, this value is extremely close to being just 8. And in fact, the instantaneous rate of change of f of x at the point when x is 4 is 8. The value of the instantaneous rate of change is the limit of these slopes of the secant line. As the x value of the second point gets closer and closer to x is 4, the average rates of change approached this number 8, and that number that they're approaching is the limit of those slopes. That limit the number that these are approaching, is the instantaneous rate of change. The last question just says, identify the slope of the line tangent to f of x at x equals 4, and that slope is 8. The instantaneous rate of change of the function at x is 4 is the same thing as the slope of the tangent line at x equals 4. Lastly, I created a few graphs of these calculations to just kind of graphically understand what's happening here. So first calculation we did was an average rate of change from x is 4 to x is 5. So the black function here is that f of x quadratic function. And I drew a dashed blue line, which is the secant line, the line that intersects the function from x is 4 to x is 5. And the slope of that secant line is 10. That's what we found when we did the average rate of change from 4 to 5. It was 10. That's the slope of this secant line. Next, we did a calculation of the average rate of change from 4 to 4.5. And again, we graphed the function f of x. And if you draw the secant line, the line that intersects f of x at 4 and 4.5, that secant line has a slope of 9. We found the average rate of change from 4 to 4.5 was 9. And so the slope of that secant line is 9. Then we got even closer. We got those 2 points even closer. So x is 4 to x is 4.1. You see those 2 points are almost on top of each other. And you draw the secant line, and the slope of that secant line is 8.2. And we could continue this where we'd have from 4 to 4.01 and 4 to 4.001 and so forth. Those points would be getting closer and closer and closer together. And you draw the secant line, you calculate the slope. The slope of the secant line is the average rate of change. Overall, you see that those lines are approaching the tangent line. The tangent line intersects the function f of x at exactly 1 point when x is 4. It does not intersect at 2 points. It only intersects at x is 4. And right at that instant, the slope of that tangent line is exactly the instantaneous rate of change of the function f of x. You could think of it as the slope of f of x at that instant when x is 4.